Ever stop and think about how your computer is doing, well, everything all at once? You've got music streaming, a dozen browser tabs open, chat notifications popping up, and somehow it all just works. It's not magic, not at all. It's actually a really brilliant partnership between hardware and software. So let's dive in and uncover the secret behind your computer's power. Yeah, we totally take this seamless experience for granted, right? But it's the result of some incredibly clever engineering. And it all brings up a really big question. Seriously, how is that possible? How can one little box manage this incredibly complex juggling act without just dropping all the balls? The answer lies in two key concepts that work together in perfect harmony: multiprocessing and multitasking. Okay, let's start with the foundation, the hardware itself. The first part of the solution is pretty straightforward. You just add more brains to the job. And that is the core idea behind multiprocessing. So what is multiprocessing really? To put it simply, it's just using two or more CPUs in a single computer. The best way to think about it is like a busy restaurant kitchen. If you want to get more food out faster, what do? You hire more chefs. Multiprocessing is basically just hiring more chefs for your computer. And hey, this isn't just some abstract theory. You're looking at the real deal right here. This is a motherboard with two separate sockets, each holding its own powerful CPU. Now, you usually see this kind of setup in big servers. Your laptop or desktop probably does the same thing, but with a single chip that has multiple cores. You can think of each core as its own mini CPU, but the principle, it's exactly the same. Build for teamwork from the ground up. And having more processors, or more cores, gives you some huge advantages. First up, reliability. If one of your chefs has to go home sick, another one can step in and take over. No big deal. Second, throughput. This is the big one. More chefs means more dishes get done at the same time. This is exactly why things like video editing or 3D rendering just fly on a multi-core machine. And finally, it's just more economical. It's way cheaper to have them all sharing resources in one box than it is to build a bunch of separate computers. Okay, so we've got our team of chefs in the kitchen. Great. But just throwing a bunch of people into a kitchen, well, that's a recipe for chaos, right? You need a system. You need to organize them. And this is where we get into the different types of multiprocessing. Broadly speaking, there are two main ways these processors can team up. They can either be a team of equals in what's called symmetrical multiprocessing, or they can have a clear boss in an asymmetrical system. Let's break down what that actually means. And this illustrates the difference perfectly. Symmetrical is like a kitchen where every single chef can cook any dish on the menu. A job comes in, and it's handed to whoever is least busy, keeping everyone pretty equally burdened. Asymmetrical is totally different. Here, you've got a head chef, that's the master processor, and they're the one delegating. They might tell a specialized math processor to only handle complex calculations, kind of like a dedicated pastry chef who only makes dessert. All right, so we've got the hardware, our team of chefs, but who's giving them the orders? Who's managing all the customer requests and telling the chefs what to cook and when? Well, that is the job of the software, specifically the operating system. And this brings us to multitasking. This is the system that the operating system uses to manage all those tasks: your music, your browser, your chat app. It's the traffic cop of the whole operation, deciding which task gets to use which processor and for how long. You can see it right here in action. All your applications, Word, a web browser, email, they all send their requests to the operating system. These individual requests are called processes. The OS then intelligently funnels those processes to the CPU, making sure every single one gets a turn. Now, this traffic cop can have two very different styles. Way back in the day, we had cooperative multitasking. This was like asking each car at an intersection to politely let the others go. It only worked if every single program was well-behaved. If one program crashed, it could just refuse to give up control and freeze the whole system. Modern systems use preemptive multitasking. Here, the OS is a strict traffic cop. It decides exactly how much time each task gets, and it can forcefully interrupt or preempt a task to let another one run. This is so much more stable, and it's why your computer doesn't just freeze up every 5 minutes. So let's bring this all together. What we really have here is a beautiful, intricate digital dance happening between the physical hardware and the intelligent software. And here is the crucial takeaway. Multiprocessing gives you the raw power,
the multiple chefs in the kitchen. But multitasking is the smart software that manages those chefs effectively. It's the combination of these two things that creates the seamless, powerful computer experience that we all rely on every single day.
And you know, this wasn't some sudden invention that appeared overnight. As one source puts it, this is a logical extension of how computers have been evolving. We've been building towards this for decades, step by step, constantly refining how these machines can do more and do it faster. It's a continuous journey of innovation. Which leaves us with one final thought. We've gone from a single processor to many processors, and from cooperative to preemptive multitasking. As we demand even more from our devices, with AI, virtual reality, massive data analysis, what's the next great leap? What will the next version of this digital dance actually look like? That's something to think about.